Okay, so find dy dx for each of the following. So if we've got y equals 4, in this case, dy dx will simply equal to 0, okay, when y is equal to 4. Because if you think about it, y equals 4 is a horizontal line, okay, that goes through the y-axis there when y is 4. And the gradient of that line is 0, isn't it? It's a flat line, okay? It's not rising, it's not falling. Steepness, well, there's no steepness to it. Flat, completely flat, so that means the gradient function is 0. Gradient is 0. Y equals 3x, well dy dx will simply equal to 3, okay? The x will just disappear, okay? Because remember now, the dy dx gives us the gradient, right? And the gradient, I mean, if we look at the graph of y equals 3x here, right? The gradient of that is going to be 3, isn't it? If you think about it, because you go across 1 and up 3, okay? Because when x is 1, y is 3, yeah? X is 1, y is 3. So, you know, the gradient will be 3 divided by 1. Rise divided by step, 3 divided by 1, which is 3. So when you presented with this, dy dx, quite simply you just say 3, the x disappears. When you've got then powers, right, such as squared, cubed, all right, to get dy dx, quite simply, you bring that power down, yeah? So if that power there is a 2, bring it down and times it by what's in front. There's 5 there, yeah? So 2, bring it down, times by 5 is 10. And then you write the x, and then you reduce that power by 1. So, because the power is 2, if you reduce it by 1, you just get power 1, won't you? And there's no need to write that. In the next one, dy dx, bring the power down, because the power is 3, bring it down, times it by that 13, so you get 39. X, and then reduce that power then by 1, so cubed then becomes squared. Often we get combination of terms, okay, you've got to expect that in the exam, but you just differentiate each term separately. So in the first term here, bring the 3 down, times it by the 6, so you get 18, x, and then reduce that so it becomes 2. Plus then, because there's a plus there, put a plus here, bring the 2 down, okay, 2 down, times it by that 2, which is 4. And then x then, and of course reduce that by 1, so it just stays as 1. So then we've got this one, dy dx, 3 terms here. So if we've got 7x to the power 4, well, I'll bring the 4 down, okay, times it by the 7. So 4 times 7 is 28. X then, well, I'll reduce that power by 1, so you get cubed. Plus then, 5x squared, we'll bring the 2 down, so you times it by 5, you get 10, so that'll be 10x. And then the 3 then, well, if you're adding 3, remember from earlier on, it's just like up here where you had y equals 4, dy dx is 0, because it's a flat line. Similar here with the plus 3, it will be a horizontal line of 3, so you're adding on 0, because the gradient is 0, so I don't need to write that. So constant differentiates to be 0. This one then, notice here you've got a negative power, right? So when I do dy dx, okay, 4y equals 8x to the minus 4. Well, same rule applies. You bring the negative, you bring the power down, right? It happens to be negative, so you bring minus 4 down. So minus 4 times 8 is minus 32, and then x, and reduce that by 1, so you get minus 5. Okay. So moving on then to the h and I. Now with h here, all right. You notice that the x term is being divided by the x term. So what we need to do before we differentiate, we need to rewrite that, okay? Because we can't differentiate it as it is. So we bring that x term up. Now remember, if I bring it up, okay, I need to change the power to a minus power. All right, we saw that in indices, didn't we? If we have a minus power, that means it's the same as 1 over it to the positive power. So when they give it to me like that, 1 over x to the power 5, take it up and write it as x to the minus 5. So then I do dy dx, bring the power down, so minus 5, bring it down in front, there's nothing there, there's just 1 there, isn't it? So minus 5 times 1 is minus 5, x then, now reduce that by 1, so if you reduce that by 1 you get minus 6, okay? And then you've got fractional power here, so we've got y equals x to the power 9 over 2, same rules apply, so you bring the power down, 9 over 2 down, so you get 9 over 2 x, reduce that by 1, so if I take 1 away from 9 over 2, use your calculator, just type in 9 over 2, take away 1, you get 7 over 2, alright? With j then, we've got dy dx here. Well, in fact, before I can write dy dx, I need to sort of write this a little bit better, okay? Because I need to, if you think about it, 19x cubed is fine. However, this 1 over x squared is no good like that. I need to take it up. So that'll be x to the minus 2 when I take it up. So it's the same power but negative of it. Plus 8x plus 3. Differentiate. So bring the 3 down. 3 times by the 19. Well, 19 times 3 is 57. X, then reduce that by 1 so I get squared. Bring that minus 2 down. So I get minus 2x. Reduce that by 1 so I get minus 3. If we take away 1 from minus 2, you get minus 3. And then plus 8x just becomes plus 8, because the x goes. And then, of course, the 3 just disappears and it becomes 0 when you differentiate it.